Okay, this recording is about systematic reviews and meta-analyses. So what do we mean by a systematic review? Let's start with that. Oftentimes in a clinical setting, we need to evaluate the literature to help us decide on what therapeutic technique to undertake, what type of hearing aid to use, what any kind of clinical decision we're trying to make should be guided by evidence, and this is one way that we do that. So by systematic, it is done according to a fixed plan or system. It's very methodical, and I'll explain a little bit more what that means. By review, we mean we're going to appraise the work, the book, the article, based on what we call PICO questions. And I think all of you will at some point go through our capstone and you will talk about this, but this is a little intro. So when we talk about PICO questions, the P stands for population, the I stands for intervention, the C stands for a comparison, and then the O stands for some kind of outcome. So if I were interested in doing a study, interested in reviewing the literature on a particular topic, I would develop this question to guide my search. Okay, and we're not going to get into all those details, but we're going to talk about kind of the the end result of the systematic review. So here's a PICO question I created. In patients with otitis media with effusion, so there's your population, and that could be more specific to say in pediatric patients with otitis media with effusion, or in adult patients, so that can be more specific. Do antibiotics, that's your intervention, improve hearing thresholds, that's your outcome, more effectively than a placebo, and that's your control. Okay, so you have all three of those, or all four of those characteristics. The meta-analysis is essentially what is done after the systematic review, and the meta-analysis is a statistical procedure that uses data from all of the studies that are deemed appropriate for the systematic review. And so essentially what it does is it pulls all the data from numerous studies to have more statistical power to find differences. So if you think about, in our field, we typically do studies with 15, 20 subjects maybe. Where you see this COVID-19 vaccine, they need thousands of participants. And so with a meta-analysis, you use, you can have one study with 10 subjects, but if you find 10 similar studies with 10 subjects apiece, now you're taking the data and you have 100 subjects in which to run your analyses versus having 10. Okay, so it basically allows you to have a stronger comparison when evaluating whatever you're evaluating. So as we look through research articles, we look at what we call levels of evidence, and it goes from weaker evidence like editorials, expert opinions, case series, case report. These are...
Here's what I found.
Oops, Siri is talking to me, sorry. Here are, so case study, case reports, case control studies, cohort studies, randomized clinical trials, and then systematic reviews are at the top, because that essentially is it's a very rigorous type of analysis. Okay. So let me give you an example from the whole COVID-19 pandemic. Early on, and I'm sure most of you remember this, the current administration was talking about a particular drug called hydroxychloroquine, and they were saying there was evidence to support its use. Okay. Other people were saying, no, there is no evidence to support its use. And essentially, both of them were wrong. Okay. There was evidence to support its use, and that evidence was more expert opinion, case reports, a few small controlled studies that were done. So when the president was talking about it, he was correct. There was smaller studies and some case reports and opinions from doctors that supported its use. What it did not have was a randomized clinical controlled trial. Okay, so and with the current COVID-19 vaccine, they're doing, you'll hear them say there's these vaccines are 90-95% effective. What they're doing is they are actually conducting quickly these randomized controlled trials, and they are, giving it to thousands of people. I don't know exactly how many, but they're giving it to a lot of people. Some are getting and they're randomly assigning individuals to either the placebo group, where it's saline solution, or it's the actual vaccine. And that is how they are able to figure out its effectiveness. So there was a lot of politics involved in this early on. I think the administration sold it a little too much. They weren't explaining it well, that there were some studies to support its use. Okay. But when you do a systematic review, you take all of this into account. Hopefully that makes sense to everybody, but we'll talk more about it in class. So why do we need systematic reviews? We want to minimize the impact of bias or error. It helps end confusion, for sure. It definitely allows people to say, well, your one study showed this, but there were 12 other studies that showed this. Highlights where there is not sufficient evidence and we need to continue to study a particular area. It combines findings from all these different studies to help highlight new findings, and then can mitigate the need for future research. So if you're interested in something or need an answer and you find it, you don't need to go and do the research. So here's the process, which I found this visual to be very helpful. Okay, so we start off with defining the research question, which we talked about was the PICO question. Then we develop a review protocol. So we specify what kind of studies we're going to include, how we're going to search for them. Okay, then we go through and we do that. We identify relevant studies through this systematic way. Then we look at each of their eligibility for inclusion in the study, and we'll talk about inclusion, exclusion criteria. Then we extract the data. Excuse me. We extract the data. We go through and get the data that we can use. Then we assess these studies. Then we synthesize everything. So we take all of the data from every study. We make judgments on how good the quality is of each study. And we run analyses and do all of that. And then we review and we disseminate the findings. Okay, so we're going to talk about here in a second here, the narrative review versus a systematic review. So if you've ever done a research paper in your academic career thus far, you have done essentially a narrative review where you have some kind of question or a topic. You find all the evidence on that topic, and then you write your review of that topic with details and so forth. So that's a narrative review, and that's what you've done so far. A systematic review is more rigorous. It has what we call inclusion criteria. So you don't include every study. There are certain attributes of a study you look for. You look for certain levels of evidence. So many times, if you think back to this, when we're doing a systematic review, we don't include levels that are this low. We would include levels maybe like cohort studies, randomized trials, and other systematic reviews. So somewhere usually around here is the cutoff. We might include case control studies, but we rarely include expert opinions or case reports, okay, because we don't consider those levels of evidence to be extremely strong in helping us make decisions. Okay, so then the inclusion, the exclusion criteria, we look at their methods. How did they conduct their study? Did they control for variables that could affect the outcome? Okay, so we look at their methods section. We look at the outcomes that need to be synthesized. So sometimes, we have to make sure that the outcomes are the outcomes that they use, the outcome measures are very similar. So we can say that this particular drug, let's say, led to this outcome. Okay. So then we look at the articles, we appraise them for their reproducibility, their quality, how were they designed, what statistics were used, and they have tools software tools that you can use to do all of these things in terms of taking the statistics that were done in a study and kind of combining them across 8, 10, 12, 15 studies. Here's just an example of a visual that I found and I thought would be helpful. And there's a ton of numbers on here, and I'm not worried that you understand all these numbers. But this is called a forest plot. And essentially, this visual shows you all of the studies for this particular analysis that were included. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this study, this meta-analysis and systematic review, they used 9 studies, okay, and they calculated some statistics called the odds ratio, okay, and then they plot this odds ratio onto this forest plot. And so they create a value, okay, as to where if the score, the mean, falls to the left, it favors this particular intervention, okay. If it falls to the right, it favors this particular intervention. So we could do anything here we wanted. So if we were doing a study like the one I mentioned where we were looking at otitis media with effusion, this one could be, if it's to the right of it, it could be favors the antibiotic, and over this side it would be favors the placebo. Okay, so if the antibiotic really has no effect, it would show that it would favor the placebo, and all of these would be on this side. So as you look at this, this is the mean score there, and this is the 95% confidence interval, meaning that you can be 95% of the time the score will fall somewhere along that line. Okay? And you can see in this case, only one of the studies falls, the mean falls to favoring whatever this particular intervention would be. Okay, and then here's your grand mean, if you will, that takes all of these into account. So in this study, the outcome favors this particular type of treatment. Okay. Let me see. Is that all I wanted to go over? So yeah, this is the forest plot. This is kind of after the systematic review when you're doing your statistical analysis, the meta-analysis. This is what you end up with. So hope that was helpful. We'll chat more about it in class as well.